these sections are for section, or these notes are for section 1.5, analyzing graphs of functions. So we tend to use interval notation more frequently in upper level math classes. It's shorter, straight to the point, but you do need to still understand inequality notation as well. Interval notation uses brackets and parentheses. The bracket means a bracket something like this, like that, and parentheses like this. Bracket means the values included at the end where the bracket is, and a parentheses means the value at the end is not included. And then values must be written least to greatest. So for example, if I had say 7 is less than or equal to x is less than or equal to 11. In interval notation, it would be a bracket 7, and then an 11, and then a bracket. So that's one example. If I had x greater than -3, it's not equal to -3. So my smallest value is -3, and I'd use a parentheses, and it keeps going. So I'd have an infinity. If I wanted to say x is less than or equal to 4, the smallest number, if it keeps going to the left, is going to go from -infinity. The largest number it's going to be is 4, and there'll be a bracket, and infinity always has parentheses. So we'll use interval notation a lot in here. We're going to talk about increasing, decreasing functions, and we're looking at the domain of those. We're going to be talking about the domain of a lot of functions throughout this whole course, and interval notation will probably be used by myself more often, but I do want you to recall both of them. Okay, we've already talked about vertical line test, and a vertical line test is just a relation is a function if no vertical line intersects the graph at more than one point. We also study zeros of functions frequently. A zero is just the x-intercept. It can also be referred to as a root, and it's a solution when an equation is y equals 0. So in this section, we're going to solve some equations and find the zeros. Okay, the big thing in here is talk about increasing, decreasing, and constant intervals. Functions behave in certain ways, and understanding the behavior of the function helps you with some math concepts. So a function that's increasing would look like this. And in Algebra 2, it's written in different ways. So it's increasing as you go from left to right, you're going up. So as x increases, y increases also. And it's fairly common sense. A function that's decreasing looks like this. So as you're going from left to right, x is increasing, y decreases. And a constant interval means there's no change in the y value. So as x increases, y stays the same. And I'll give you more examples like that for the live lesson. Then we also talk about relative minima and maxima. A relative minimum is 1. A minima is plural. Same with maximum. A minimum is going to be the lowest point. So if you have a graph that looks like this, it's a polynomial of some sort. It has a relative maximum here. It's not the highest point because look at this, it goes higher over here. It's just relative. Right here, it has a relative minimum. This is a relative max. And this is a relative minimum. These points are important because the function's changing at those values, and that's why it's important. You should be able to find a relative minimum and maximum values with and without a calculator. And then the one concept that's completely new to you is this idea of even and odd functions. And even and odd functions, I will go over several times in here. And the first time I go over it, the majority of students don't quite grasp what I'm talking about. So an even function, there's some characteristics. Even functions have y-axis symmetry. And to test it, you're going to test f of negative x and see if it equals f of x. And we'll do more of this later on. So if I had this point, say I had this point 3, 1. So 3, 1 is what I would refer to as x, f of x. If I made the x negative, it comes over here. It's the point negative 3, 1. So you see the x is negative, but the y stayed the same. So that means you would have the point negative x, f of negative x. So in this case, f of x is 1, f of negative x is 1. So they're the same. And there's lots of functions that you guys have studied that are even functions that have y-axis symmetry. Off the top of my head, I can tell you that if you have a quadratic, if it is symmetrical around the y-axis, that's an even function. Same thing with the absolute value function. If its vertex is on the y-axis, then it's an even function. And the important characteristic about those is whatever you see on one side of the y-axis is exactly the same as the other side of the y-axis. Odd functions have origin symmetry. Which means f of negative x is going to equal negative f of x. If I took the same point 3, 1 again, so I'm going to make x negative, which gives me negative 3, and that's going to make my y negative, which gives me negative 1. And that is origin symmetry. So whatever you see in the first quadrant is reflected in the third quadrant. Likewise, if I had something in the second quadrant, it would be reflected in the fourth quadrant. There are some odd functions. We'll study some here. The one that I can think of off the top of my head would be this y equals x cubed. If you have y equals x cubed, it looks like this. And we're going to study this function later on. So everything that you see in the first quadrant is reflected over the y-axis and then over the x-axis. And it's in the third quadrant.